Welcome to a lesson with Dr. Powell. Let's take a look at another type of function where the input is actually a vector, or there's two different things to consider the input. What if we take something like this, where we let z be the output of a function? Maybe let's just do something like 2x plus 3y plus 1 or something like that. This, if you look at it, rearrange it, is an equation of a plane. And in general, however this plane looks, if you take a coordinate right down here in the xy plane and you plug that coordinate in here, it'll output a z value. And you go up to that z value, you could think of that as altitude. Now, with that being the case, you should be able to get a plane. In fact, in this particular case, you can kind of think, well, okay, so if y were 0, for instance, so if y were 0 right along here, then it's going to look like 2x plus 1, so it's going to be kind of like up there. And if x were 0, so right here, we're going to get, it's going to look like 3y plus 1, so like this. So you're going to really get a plane that comes off like this right here. You can kind of see a kind of a plane coming here, kind of coming toward us a little bit, and it would come up here. So we get a nice function, right, with that as being output. So we're going to consider what it means to take the derivative of this function, and it's going to be a function that takes us from run, and it's going to output rise at a particular value. Okay, our xy value, right? Because the input is kind of a whole xy coordinate and the output is an altitude. So we're going to think of the derivative this way, from run to rise. Well, and we're going to do that in terms of projections. So here's an idea. What if, we'll just look at a plane for maybe this vantage point right here. And let's suppose at a particular xy value, we're right here. And so maybe this is xy, and to make sure this is actually on the curve, it's on the surface itself, the plane itself, maybe I'll add in a z value. So f of xy, okay? Then if we go to another point right here, where we changed our run, our input, by just a little bit, so maybe I'll just notate this over here. So x plus change of x, so we've changed it a little bit. Y, we've changed a little bit. And then we have f of just whatever these are, there and there. Okay, so we're on the curve, but basically change of x, or x and y, have changed a little bit. Then we look at this rise. Now, if we were to draw a line through the vertical, because it represents the z values, and we would take the projection of this line onto that vertical line, that would be the rise, okay? So we want kind of something like that. If we input some kind of run, change of x, change of y, we want to output a rise, and that rise is going to be the projection there, okay? We're going to get the rise, and we're going to get one rise out of this, not three different rises, but just one single rise. But we're going to have it's like we have two different runs to make one run here, because the runs are actually like vectors here in different, with two different components. Now, how can we do this effectively? Well, what if instead of just doing this overall, what if we just did only in the x direction? So what if y didn't change at all? Maybe just x changed. So maybe this is the x direction. Okay, maybe we'd go to here. Then let's go just in the y direction. We'd go to here. Now, the nice thing about this is that projections respect vector addition, meaning that if a vector is equal to the sum of two vectors, then the projection of each one of those in the sum, so the projection onto this in the vertical plus the projection on that on the vertical, is actually going to be equal to the projection of the whole vector right here onto the vertical. Very, very nice. And so we can just think about in terms of finding this projection and adding that projection, and we actually get the total rise. So the total rise is going to be by finding the rise in just the x and just the y and adding them together. Kind of a nice idea. So how do you find the rise in just the x direction? Well, it's nothing other than, well, first we just need the slope in just the x direction, because isn't that just a line? Hey, that's a straight line in the x direction. In the y direction, hey, that's just a straight line in the y direction. We're back to single variable calculus, straight lines. So for instance, if the y variable were constant here, you could think of all this whole thing as a constant. And this is just 2x plus some constant with the slope of 2. So the rise in just the x direction is going to be 2 times the change of x. So see that change of x is the run, and then to have a right, and then you're going to have 2 times change of x, so that when you take the ratio of 2 of this over this, you just get 2, which is this desired slope, which we see right here. So likewise, the rise in just the y direction is going to be 3 times change of y, because if x is constant, that's just a constant plus 3y, slope 3. So the rise will just be that. And so we see that we can compute the rise in such a way. Now, how do we get this? Well, we usually do this, or how do we notate this? We usually notate df as a matrix as follows. Since we have two inputs, then we're going to have 2 columns, one for each input. And since we have one output, we're going to have only one row. So outputs correspond to rows and inputs correspond to columns. So here we notate this by saying simply 2, 3, where this 2 corresponds to the input of x, change of x. This 3 corresponds to the input of change of y. Now, if we'd evaluate this, we actually evaluate this by doing as follows. The input we always write as a column, like this. And then a little matrix multiplication is the same thing as dot product. Matrix multiplication is simply taking a row and a column like this and taking a dot product of them. So 2 times change of x plus 3 times change of y is actually equal to the total change, or the total rise of the function. So that is why we usually notate, so we want to talk about the derivative of a function here. This, in this sense, this would be the derivative. It would be a matrix with 2 values, the derivative in just the x direction and the derivative in just the y direction. Thanks for watching.